Okay, on problems number 19 in that section, I noticed that we kind of needed a video in there in case we don't get through it in class. It says find the values of the 6 trig functions. Okay, we already know what the tangent is. And I'm going to just try to keep my answer list going over here. This would be cosecant over here. Inverse of cosine would be secant. And we know we have our tangent. We already know what our tangent is. It's negative 15 over 8. So I can go ahead and flip that one to get the cotangent, and it's going to be negative 8 over 15. So I've got those two easily. I need to find the others, though. Now, the only thing I know is that the sine is negative. Sine less than 0 means the sine of the angle is negative, and so they want all the values. So let's think about this for a minute. If you think about all students take calculus, if you think about which trig functions are positive in which quadrant. If I want a negative tangent, that can only happen here or here, because sine's positive there, cosine's positive there. It means in those two quadrants, tangent would be negative, just because it's not the one listed. I also want the quadrant where the sine is negative. Well, in quadrant 2, the sine is positive. So what they're telling me really is that I want to work down here in this 4th quadrant. That's where the sine is negative and the tangent would be negative. So you're going to have to kind of think that way in all these problems in here. Okay, so I know that much, right? Now, it has to be in quadrant 4, so let me go ahead and draw it down there. I'll kind of draw the angle, I guess, in green. Whatever this angle is, it's down here. One thing I could do before I actually get started on it is say, well, if the sine's negative down there, which they already told me, I could just go ahead and put a negative on those answers so I don't forget it at the end. The cosine there is positive in that quadrant 4 because of that C being there in the little memory device. So I could just go, okay, my cosine and secant are going to be positive. So one thing I do is I try to make sure I get my signs ironed out before I figure out the numbers, and that's just some advice that I would give you, is that maybe that might help you not make mistakes on those kinds of things. And, since we know what quadrant we're working in, we kind of know how it's all going to turn out. All right, so here's the other thing. You got to think about SOHCAHTOA. If I've got this triangle drawn, here's my right angle in it, this negative 15 over 8, if you think about it, this is opposite over adjacent. SOHCAHTOA says tangent is the opposite over adjacent. So my opposite side is going to have the number 15 on it, and my adjacent side is going to have the number 8 on it. And then my hypotenuse, this is a special triangle. This is 8, 15, 17. So this is going to be 17. There's that triple that I really kind of want to remember. Now, if you look at this, we could figure out the signs of everything. We don't have to use the memory device to figure out the signs, but it's just a handy little thing to use. Let me go ahead and show you. If this is my x-coordinate, it's a positive 8. This y is going down, so this is a negative 15. I could figure out my signs without ever thinking about that memory device. It's just a quick way to kind of summarize it, so I can either check myself or I don't have to think so hard. If I want the sine, this SOHCAHTOA is again what I'm thinking here. The sine of this angle is the opposite, which is negative 15. And I already wrote my negative sign down, so I'm just going to notice that I already had it there. But it would be negative 15, and the hypotenuse would be 17. So the cosecant will just be that fraction flipped. And again, I had already written the sign because I knew, because cosine is the only positive one there, I knew my sine numbers were going to be negative. So I could just kind of, if I'm using the memory device, you can kind of just ignore the negatives that you make on this triangle down here when you're working it. Now, the only one I've got left are cosine and secant. The cosine is adjacent over hypotenuse, so if you look here, the adjacent side is 8, and the hypotenuse is 17. Cosine is positive in that quadrant, but even if I put those numbers over themselves, they would still be positive. And then to flip it, I would get 17 over 8 for the secant. And I've got all my trig functions. Okay, problem number 23 is the same type as we did in problem number 19, but it says the cotangent is undefined. Anytime I see something that has like 0, 1, or undefined in it, I'm pretty sure I'm not looking at 30, 60, 90s or 45, 45, 90s. I want to go to my unit circle and think, okay, I'm thinking about these points here. The reason I know this has something to do with these points on the unit circle, let me just go ahead and fill them in. So 0, 1, and 0, negative 1. So if you think about it, how do you get an undefined fraction? Let me write something else first. First of all, cotangent is the reciprocal of tangent. If tangent is opposite over adjacent, cotangent is going to be adjacent over opposite. Okay. We also know something else about this. And this is kind of where I want to go with this when I'm looking at these 4 points. A lot of times adjacent and opposite don't tell me anything because you can't really draw a right triangle when you've got a point right there on the axis. It just doesn't work out. So the other thing I remember is that tangent is y over x, so cotangent is x over y. And this right here is the thing that's going to help me get through this problem. Because you see, if I have an undefined fraction, if cotangent is undefined, and it's x over y, I know that an undefined fraction is something that has a 0 on the bottom. So what I'm thinking is, which points here, which of these 4 points, and I'm limiting myself to these 4 points because they're the only ones that have the zeros in them, which points have a y value of 0? Well, the only ones that do are this one and this one, don't they? I have the point 1, 0, and that's the angle 0, or 2 pi. And then the other one I have is down here. This is pi down here, isn't it? And so, but it's only one angle. And here's where I got to look at what the constraint is up here. Remember, they gave you this thing that they called it the constraint. It's right up here. I'm circling it in purple. My angle that I want for my answer, I only want one. And it's between pi halves, which is 90 degrees. I'll color it in purple here. And it could be 90 degrees, or it could be anywhere between 90 degrees all the way down here to negative 3 halves pi. It's somewhere in that vicinity where I made that purple, mark there. And they're saying it could be 90, and this 3 halves pi, that's the same thing as 270, right? Well, which of the 2 angles that I found over here, these 2 right here, which of them is between 90 degrees and 270? Oh, not this one, is it? It has to be this. My answer is pi. So that's the reason there's only one answer for that, and it's a different thing, and that I have to go to my unit circle, but I'm not looking at my 30, 60, 90s or 45, 45, 90s. The other tool I have to look at are those points that fall on the axis on the unit circle. And so that's how we would do 23. 39 tells us to find a reference angle for the special angle. And the reference angle is the one we're going to use to actually look at for our trig values, and then sketch it and sketch the angle and the reference angle in standard position. Okay, so for 39, it's negative 135 degrees. All right, if I go in negative 135 degrees, I'm going counterclockwise here. Let me write some things in. This is 90 degrees, 180 degrees, 270 degrees. Well, I'm going counterclockwise, so let's think about this. 135, if I go, it's kind of like I'm starting here. Well, if I go 90 degrees, I'm not there yet, so let's take 90 degrees out. What's this going to be? Oh, there's 45 degrees left I need to go. So this right here would be my 135 degrees. Now, the thing I got to pay attention to is this little thing right here. This was a 45-degree angle in here, wasn't it? Now, what my reference angle is, let me draw it in green. My reference angle is the angle that that ray makes with the x-axis. And so it's right here. And what I'm going to do is take that angle and draw my right triangle like this. If this angle right here was 45 degrees, I know this is a right angle. I know that quadrant 3 is a 90-degree right angle within the coordinate system. So what's 90 minus this 45 that this took up over here? Well, that leaves 45 degrees for this. So my reference angle is 45 degrees, but it's not the 45 degrees that I figured out right here. I actually had to say 90 minus whatever I got here, which just happened to be 45, would be 45, and that's what my reference angle is right there. So they just want you to just sketch that there. Let's look at 43. We have theta is equal to negative 5 pi over 6, and it's the same thing instructions as the 41 we just got done. They want us to sketch the angle and its reference angle. When they say this theta prime, they're talking about the reference angle. Okay, so let's think about this. 6 over 6 pi would be the same thing as 1 pi, wouldn't it? Okay, so it's a negative angle, so I'm going counterclockwise. This angle, I'm not going to go a whole pi counterclockwise. If I was, it would be like negative pi or negative 6 over 6 pi. So we know it's not quite there. Now let's think about it. If I were to go, let's think about this. If you think in degrees, it just makes it easier. What is 5, 6 pi in degrees? Well, it would be 5, 6 times 180, wouldn't it? Because we can just replace the pi with 180. Oh, this is like negative 150 degrees. So let's think about that. Here's 90 degrees out of the 150 degrees. So let's do this. When I subtract that, I get, I need 60 more degrees. And so this is 60 degrees here. Here's the 90 degrees. We went past, the past quadrant 4 into quadrant 3. And so it was 90 and then 60 more. So this is a 60-degree angle. Now my reference angle that's my regular angle. That's my theta. My theta prime, my reference angle, is this angle right here, the angle that this makes with the x-axis. And remember, what I'm going to do with this to find my trig values is make a right angle out of this. So what is this little angle? Well, this right here is 90 degrees, isn't it? So if I took up 60 degrees of that 90 degrees, basically I'm taking 90 and subtracting this 60 out here. Oh, what I had left up here was 30 degrees. Now, since they gave it to me in radians, I don't want to say that's 30 degrees. I'm going to write that is 30 is the same thing as 180 divided by 6. So that would, if I substitute pi for 180, that would be pi over 6. So that angle right there, the reference angle, is pi over 6. And that would be the sketch that you'd want there, but you would just, a lot of times it's easier for me to think in degrees again and then switch it over to radians at the end.